Elementary Science Class 7. Electric current and its effects. Symbols of electric components. Do you know, Maisie, that electric components can be represented by special symbols?
No, I didn't know that. What do these symbols look like?
Well, let me show you. In this table, you can see the symbols for some common electric components, like cells, batteries, switches, and wires.
Wow, that's really interesting. How do these symbols help us understand electric circuits?
Great question. The symbols make it much easier to draw and understand electric circuit diagrams. For example, the symbol for a cell shows the positive and negative terminals.
I see, that makes sense. And what about the symbol for a battery?
The battery symbol represents two or more cells connected together. In a battery, the positive terminal of one cell is connected to the negative terminal of the next cell.
Ah, I understand now. And what about the switch symbol? How does that work?
The switch symbol shows the on and off positions. When the switch is in the on position, the circuit is complete, and the components can function. Heating effect of electric current. Did you know that electric current can produce heat when it flows through a wire?
No, I didn't know that. How does it work?
Well, let's try an experiment. If we connect a bulb to a battery and turn on the switch, the bulb will start to glow. That's because the electric current flowing through the bulb is producing heat, causing the filament to heat up and emit light.
Wow, that's really interesting. Can you show me another example?
Sure, let's try this. We'll take a piece of nichrome wire and connect it to a battery. When we turn on the switch, the wire will start to get hot.
I can feel the heat from the wire. How does this work?
The heating effect of electric current is caused by the resistance of the wire. The more resistance the wire has, the more heat it will produce. That's why some electric appliances, like heaters and ovens, use coils of wire to generate heat.
That makes sense. Can you give me an example of where this heating effect is used?
Absolutely. Electric fuses are a great example. They use thin wires that are designed to melt and break the circuit if too much current flows through them, preventing damage to the electrical system and potential fires. Magnetic effect of electric current. Okay, let's try this experiment with the electric current and the compass needle.
What are we going to do?
First, we'll wrap an electric wire a few times around a cardboard tray from a matchbox. Then, we'll place a small compass needle inside it and connect the wire to an electric cell through a switch.
And what happens when we turn the switch on?
When we turn the switch on, we'll see that the compass needle deflects. This shows that the electric current flowing through the wire is creating a magnetic effect.
Wow, that's really interesting. Why does the compass needle move?
The compass needle is a tiny magnet that normally points in the north-south direction. But when we bring a magnet close to it, the needle gets deflected. Similarly, when the electric current flows through the wire itself behaves like a magnet, causing the compass needle to move.
I see. So the electric current can create a magnetic field, just like a regular magnet?
Exactly. This discovery was made by a scientist named Hans Christian Ørsted, who was the first to notice the deflection of the compass needle when electric current was passed through a wire.
That's amazing. I didn't know electric current could be used to make magnets.
Yes, it's a fascinating phenomenon. The magnetic effect of electric current has many practical applications, such as in the creation of electromagnets and electric motors. Electromagnet. We'll do a fun activity to see how an electromagnet works. First, we'll need a piece of insulated wire, about 75 centimeters long, and an iron nail around 6 to 10 centimeters long.
Okay. What's next?
Great. Now we'll wind the wire tightly around the nail to form a coil. Then, we'll connect the free ends of the wire to a cell through a switch.
Wow, That's interesting. What happens when we switch on the current?
When we switch on the current, the coil will behave like a magnet, and the pins placed on or near the nail will cling to the tip.
That's amazing. And what happens when we switch off the current?
When we switch off the current, the coil generally loses its magnetism, and the pins will no longer cling to the nail.
Wow, so this coil is called an electromagnet. That's so cool. Where else are electromagnets used?
Electromagnets are used in many applications, such as cranes, separating magnetic materials from junk, and even in some medical procedures to remove small magnetic objects from the eye.